We're given an array of integers nums, which is sorted in ascending order, and an integer target. And they want us to write a function to search for target and nums. And if target exists, then they want us to return its position. Otherwise, return -1. And they want us to write an algorithm that runs in big O of log n runtime complexity. So this is a pretty basic binary search problem. Um, so that's exactly what this it's exactly the algorithm this problem is suggesting. I mean, obviously the title is binary search, but basically if you have a sorted array, anytime you have a sorted array, you can do a binary search, which it runs in big O of log n time. And basically what that means is instead of like big O of n time where you have a function that grows in asymptotically bounded linearly, it'll basically uh, be asymptotically bounded logarithmically, meaning the search space with every iteration gets cut in half, as opposed to only getting knocked down by one element, right? So there's a massive difference. Log n is like way faster. So yeah, let's just, I want to just walk through the algorithm, the binary search algorithm first, using an example, and then we can code the solution. So let's go ahead and do that over here. So we had a -1, a 0, and a 3, 5, 9, and 12. And the target is 9. Okay, so the way our algorithm is going to work is we're going to have a left pointer, a right pointer, and a middle pointer. And let me just write these indices first before I get into how that's going to work. So, okay, so these are the positions of the elements. This is our array. These are the values. This is our target here. That's 9. So at first, our left pointer is going to be on the 0th index. Our right pointer is going to be on the last element. So in this case, it's the 5, position 5. And then our midpoint is just going to be right in between our left and our right pointer. And the way we're going to determine that midpoint is we're just going to say index of right plus index of left divided by 2. And that's going to give us our midpoint every time. So, and then rounded down if it's even the number of elements here. So it's basically it would be this 2. So we have 5 plus 0 divided by 2. And then that would basically be 2, because with integer math in C++, if we get a 2.5, the 0.5 gets truncated and you get a 2. So this would be our midpoint to start. And we're basically going to loop. We're going to have like a while loop, and we're going to just keep looping while our right pointer is greater than or equal to our left pointer. And the equals to is important because if there's a chance we might not find the target, and we have to exhaust that possibility by basically collapsing our pointers onto each other. And also at that point, you could potentially find the target as well. So anyways, yeah, we're gonna do while right is greater than or equal to left. And the first thing we're gonna do is we're gonna check. We're gonna always check if our midpoint, the value at our midpoint is equal to our target. So in this case, it's not. So that would be the first check. So I'm just going to put an M here. So we're going to check the midpoint value. And then the second step is going to be, we're going to check if our target is basically greater than the value of the midpoint, right? So if our target is greater than whatever the midpoint is, we're basically trying to collapse our search space, right? So this is like our search space. we're going to check if the value of the target is greater than the value at this midpoint. If it is, then we can go ahead and search right, and we can collapse our search space by basically moving our left pointer, because we've already checked the midpoint and we know it's not going to be this way, so we can just move our left pointer over here. And then like vice versa, we can do the same by collapsing our search space and moving the right pointer this way if the target is less than the midpoint, right? So in this case, obviously the target is going to be greater than the midpoint, so we can move our left pointer here and go on to the next iteration. So let me delete this. Yeah, so let's calculate our midpoint. So it's going to be 5 plus 3 divided by 2. So it's going to be 4. Okay, and we can check, is our midpoint equal to the target? It is. So at this point, we would just return 4. And that's pretty much it for the algorithm. The time complexity is going to be big O of, not big O of n, big O of log n, right? The search space gets cut in half every time we iterate, which is way better than big O of n or linear. And then for the space complexity, we're not going to be using any additional space. So we can just say constant space. Yeah, so let's do the code. So the first thing that we want is a left pointer, and I'll just keep this nice and short. So just use L. We want a right pointer. That's going to be the last index in our array. So it's going to be the size of the array minus 1. That's how we can find that. And then we're also going to have a mid pointer. That's just going to be equal to left plus right divided by 2. And let me put some parentheses here just to make sure this evaluates properly. Okay, so we're going to loop while our right pointer is greater than or equal to our left pointer. And at the end, if we don't find anything, we're going to return minus 1. So let me just put that in. And then the first check that we're going to do is, well, we're actually going to calculate our midpoint first. So, you know, I don't even really need to do this calculation here, but let's just instantiate it. And then just to keep this a little cleaner, we'll do this calculation in here. So that's going to be the midpoint. And then we're going to have a couple conditionals, right? So the first case is we're going to check if nums at m is equal to the target. If it is, then we can return the midpoint because that's the index, right, where the target is. Otherwise, we're going to want to look left or left and right, potentially, right? So first, let's check, okay, is nums m, so is whatever value of our midpoint, is that greater than the target? If it is, or actually let's do, yeah, just to mimic the way I did in the example. So if this is, if the target is greater, right, than the value of that midpoint, then we'd want to search right. And how do we do that? Well, we'd have to move the left pointer, shift it towards the midpoint plus 1, right? And then the only other case is if the target is less than the value at that midpoint. So just to keep this a little bit cleaner, I won't actually hard code that in. So we know it would have to be, you know, we already checked if it's equal. Then we asked, okay, is it greater than the value at the midpoint? So the only other thing is if it's less than the value at the midpoint. And if it is, it would just be, we would move that right pointer down to midpoint minus 1. So that's pretty much it for the code. Let's go ahead and run this. And yeah, that's binary search. So hopefully this is helpful, and I'll see you guys in the next piece.